Okay, welcome class. This is to week 4. We've now started the downtrend in the completion of this effort. Start my video. Yeah, okay, there we go. All right. I hope everyone had a great productive week. A lot of good work done. Some progress made to make things better. I'm seeing a good trend upward of our grades and our time put into this class, which I'm liking. There's a lot of positives coming out so far, and I hope everybody's learning things that are interesting to them and how they can make use of this type of capabilities for when they get into their career. Let's open up chat. Okay, here we go. Keep looking over here for the chat. Okay, great. And I hope everybody can hear me just fine. All right, well, I will take nobody say anything they can't hear me. Okay, so this week's lecture is going to go over some other types of capabilities within spreadsheets that are used for problem solving, to include functions like ranking and other capabilities, as well as some additional work on pivot tables. Like I said, I'm seeing a decent trend upward. Now we're having more than half the class, probably, or close to half the class, doing really well in this class at this point. Timelines make sense. I would like to see more work in it, but at the same time, it's not hard. It just takes effort and time. And therefore, I'm going to continue to accept all the assignments back to day 1. Albeit I may add a late tardiness penalty to discussion boards. So that way, if you need to, you can work on improving your overall grade score within that context. But so yeah, I'm going to go ahead and continue to accept all the old homework. I know that people that got impacted with the lack of electricity in Texas, there's a couple of people in this class that I've heard from. I don't know if I heard from everybody. If you're one of those people, and I do deduct tardiness penalty, remind me, and I will remove that tardiness penalty and give you back those additional points on any other late submissions you make. Sometimes real world events impact all of our lives, and you can't do anything about bad weather. But all right, so in the discussion board this week is going to be about pivot tables and how they can be useful in making decisions. Now, does that necessarily mean you need to do it as a budget? No, not necessarily. But what it is pivot table can be used to give you views into data sets so as to make important decisions in your business or your future or your make decisions about stuff by having insight into your data set. So there's a nice little video here on pivot tables and pivot charts. I'm going to go ahead and I'm going to prep it. Sorry. I'm going to prep that video here because I may use that later today. Okay. So there we go. All right. In unit 4 of IntelliPath, you'll be talking about worksheets, workbooks, databases, how to import external text files into database, into Excel, and what that can mean for you in order to build your data sets, and then how to build your pivot tables and what they can benefit you from. So in Excel, a database is effectively a relational table, or it could be or a set of multiple relational tables, in that you can have multiple data sets that all interact and relate to each other, that in that you can pull information from each of those in order to build a bigger summary dashboard page, or dashboard or summary table set, so that you can then do pivot tables against that in order to better extract and understand your data you have, right? So all that being said, all right, that was bugging me. Oh, really? That's weird. I'll have to fix that later. All that to be said, that you could have large sets of data, large sets of information, to be able to help feed into understanding what your actual data set. So the pivot tables give you insights into views into data. One of the examples, I'm going to jump over to here on this spreadsheet. So in this context, this is what you're looking at, is what a pivot table looks like. So the data set, which was based on, here we go. This data set here initially was then used to create a pivot table like this. From that pivot table, we could then build in charts and data to reflect how various pieces go. So if I were to look at this, I could say, all right, show me all of the summary of just years 1 through 4 of how the students are doing in what percentage of the classes, or how many percentage of students in a given year. And you can kind of see that from the stacked bar chart. If I were to change this chart type to, let's go to this style, you can get a feel for, well, in this case, I have, looks to be 14, 15 people in the 4th year of a student, right? So if I re-show the different classes, that pivot table then changes, so that, or the pivot table changes, showing you the other pieces of data, because I'm now showing course data. But you can watch the chart. The chart will actually change how it's viewed, so that you can get more information into a particular piece. Now, if I wanted to take out, say, student levels, and this tells me number of students in a particular class, regardless of number of what year that student is. But if I need to know what grade a student is, number of students in a particular class, I have to show all of it, right? So now if I were to, like, take, say, change my axis from, let's change that like this, right? See, if you have this in the wrong order, it doesn't seem to make a ton of sense in this context. So moving this down there, if I move this over here, you can get a better feel for the, tries to summate the years, which doesn't make a ton of sense, but it at least gives you the summary of the years from the table of the students in the different classes. But in this context, right? So, all right, where did I mess it up at? There we go. Anyways, my point is, you can get a view for how these are laid out. So now I got it now confused, because I got it so to start summarizing all the numbers here for different pieces. That's not quite what I wanted to do. So let's see if I can. No. All right. Anyways, get back to something that made sense. Sometimes you have to play with it in order to get it to show what you want to in that manner. So that's how you can use pivot tables to help with understanding the bits and pieces. You can get different views into data, so you can alter your view of the data source itself because that whole time I did not touch what my data source was, which was over here, that was used to build those pivot tables. So, but you can see how you've seen how the pivot table chart graph dynamics actually then updated real time based on how you're reviewing that data. So, okay, hope that all made sense. Like I said, depending on how fast we go, I might bring up this 9-minute table, my 9-minute YouTube video to help with that. All right, so database functions, things like MS Access or other tools like it, like Oracle, versus what a spreadsheet does, right? So the differences is in that in Excel, you're using a data set, but you're doing everything in memory, and it only matters when you save it. Newer versions of Excel have added the ability to be integrated in with SharePoint or OneDrive in order to allow shared spreadsheets be able to then dynamically update, or you can do updates with other users via web page view of Excel, so that you can see both people updating the cells in real time. But other than that change, generally spreadsheets work in memory, and you only commit your changes when you save to memory. Databases commit changes every time a change to any given piece of information is made. So it always stores everything in a storage array or a storage system or hard drive or something along those lines, such that all the information is always there. Whenever you make a change to any piece of data, it gets instantly committed to that particular piece. And you can usually have a log of changes being created, so that at times you can go back and figure out what it is you changed over time. But in Excel, it's all done in memory. So your changes need to be such that if you did a lot of work over a period of time in Excel and then your Excel happens to crash, which does happen, and in the field you will always run across scenarios where that occurs, you may sometimes have to work on restoring your data, or you may have to work on recreating the changes you just made to that Excel spreadsheet because it only had it from the last time you saved. So that's really the biggest difference between a database versus a spreadsheet capabilities is it works from storage. Now, when deciding to use either a database or a spreadsheet application, it's a good idea to understand the reasons as to why. In IntelliPath, it wants you to choose a very large data set as to the reason as to why you would choose a database over an Excel spreadsheet. And in that context, that data set is hundreds of thousands of cells or pieces of data or more that is constituting that. That's what makes it, quote, very large. Though nowadays, with the way sensors collect data 24/7, 365, how we do heart health monitoring systems, how we do fitness tracking, how we do sensor data for satellite tracking, all those different things now. The definition of very large, and according to this text, was 5 years ago, was roughly 100,000 cells of data. Well, that is now considered not that large. In fact, I would even consider that's average of small based on how sensor data now gets recorded in the world, where we could have very large data sets be in the hundreds of millions of cells of pieces of data that's then used in time. So hope that made sense. All right. There's different ways to import text files. You could do it by using text import wizard. You can do it by copy and pasting from a text page. You can import CSVs. And in the 2016 version of Excel, it was limited to only 1 million rows. Nowadays, that limitation is no longer true. It's they changed it from a 32-bit system to a 64-bit system. So this potential limit now has gone exponential compared to that. But that's also back why they decided very large data sets were roughly 1 million. So that's why they had to use other tools that were capable of it, and when Excel wasn't. So I gave you some tips and tricks on how to do I showed you how to use the right and left functions. Here's some neat tricks to have if you need to like remove trailing spaces from your given set in order to normalize your data so that you can get it to organize correctly. Say you had I'll just go make the data set like that right now. Let's see, where is it? Something I can do. Yeah. So trailing spaces are like this, right? Oops. But what it does is it makes your cells be unique with that spaces. So then you start getting cases of, all right, information security, where you at right here, where this doesn't pick up that there's now 2 of these because it's no longer a unique name. So you'd have to recreate your pivot table to add in those particular pieces. Oops, went too far. Okay, back to data set. But now if you go back to here, I was looking at introduction IT, right? Now, if you back here, you can see that it recognizes both of them because they are no longer unique pieces of data. So trailing spaces can be a problem at times. There we go. But it's hidden pieces inside of your spreadsheets like that, or you could say removing leading spaces for the same reason. The thing is you can do that in order to normalize your data so you can get a pristine data set in order to do your analysis from. So that's a couple of nice tricks to have in your back of your book when you're using these for solving or trying to figure out why it is. Because a lot of people will sit there and it's like, well, I can't figure out why these two things are different. They're being treated differently. And it usually has to do with trailing spaces. So, but you can do that with the left and lean, and then all you do is you run that against, I'm gonna go copy this just to show you. So if I had, oops. See, I put a whole lot of trailing spaces in here, right? So if I were to adjust this so that it points to this cell on all of these, oops. Oh, hit the wrong button. When I go to this piece of data, I can then get this, copy it, put it back, and put it back as text values. And I no longer have all the leading cells, all the leading spaces that I had before. So there we go. Sometimes you do that more than once. You have a lot of extra spaces. And for that same piece, then you could go like here, copy paste like that, and you just oh, that's because it's I have so many extra spaces. Let's just do with one. Right. All right. So one space. Yep. There you go. So, anyways, that's how you can do it. You can do the same thing with leading spaces with this other line. Just have to manipulate it once, but it allows you to get rid of it. That way, you can then better use your other tools such as delimiters and stuff to set up your pivot tables. You can do advanced filtering in when IntelliPath asked I want to display rows that only meet certain criteria or conditions. You can accomplish that through filtering. That's how you get it to come down to just certain things based on the data. What is extracting? Extracting is a process you can use to copy transfer data from one part to another part for comparison. You just saw me basically do that. So yeah, if I took this piece here, I did this in order to make it. If I copy search values, that's a case of like what that is just talking about right there. But it's different than exfiltration, which is an unauthorized theft information that can be used or removed from the system, potentially for dangerous purposes, primarily used in things like identity theft, where people exfiltrate information as opposed to extract information. Oh yeah, I came over this last time. All right, so one of the questions that come up in Telepath that people get wrong all the time is a way to display graphs and tables and charts. So you can do that by embedding the tables. So that's what the OLE function comes in, right? It gives you the ability to embed a table within a Word document so that every time you update the table, the Word document automatically gets updated as well. Additionally, you can then use Excel to build out better Word reports, PowerPoint presentations and whatnot, so that your data is always consistently updated, and that when you actually use it for presenting or creating reports, it is consistent with your data source itself. So that's where the OL linking comes in this context. That should be listed as part of a database function inside of a Telepath. Often used together primarily for like financial reports and whatnot. So that is important to know because when you do that linking, it's usually there because you need to have something that extracts money or extracts sensor data out that you're needing to then show and show to others in presentation level type quality. So, but yeah, so you can link Excel and Word through that process. As you can see here, this is just a pictorial of something where I had a spreadsheet that I was using to do part of my dissertation with, and I used it to update my Word document so that my tables would be updated dynamically when I need to. One of the math functions inside of Excel is the product function, which allows you to then take two sets of numbers with the product formula here, and say 1 and 6 be these two cells. It will come back to that. What it does is it multiplies 1 by 6, 2 by 7. So it's the same thing as just doing sum cell times cell. But the thing is, with product, you can then do it over a range of large numbers of cells in case if you're looking for like large quantities of things. So you can do it for more than just specific cells, or you can build a product where you can just build out your data set and you can use the product function across the entire data set at once and not have to worry about building individual formulas. So ranking concepts. So ranking is a means by which to tell it to, I want to sort by, or the data is unsorted, for instance, and once you need to find information out on that data set without it having to be sorted, without it being sortable, but you can get it to then tell you information such as what is the top or bottom percentage of some piece, right? So if I were to like take 9 values here of 1 through 15 and say, all right, I need to know what is the average versus of this set of data, and I can do that by figuring out the sum of 1/3. But if I wanted to do it based on ranking, the thing is with ranking, you can then use a function and it will tell you what order it is in that data set. So if I took the unsorted list here of those same numbers and I use the rank command, all right, saying of this entire set of numbers, tell me what's ever in the increasing order, it'll tell me increasing order is from 1 to 1 plus, as opposed to decreasing, which is the highest and the lowest. It'll tell me what this value is in relative to that list of numbers. So if I took this whole number set here and I just happen to bring it over here and I manually sorted this correctly for just this one set, you can see 1, 2, 4, 5, whatnot, right? So you can see the first, second, third order of this numbers out of these 9. If I wanted to know what 5 was, but I didn't have it sorted, I could say, all right, use the rank function. Tells me 5 is the 4th number in the list, which is what this is. Same thing, if I wanted to figure out what the value 9 was, it'll come back saying it's the 7th number in this list. So rank is useful in order to extract yeah, screw it. Keep that. So rank is useful in understanding how you can determine the spot within this data set of that value relative to its position and everything else. Now, if you wanted to take like an average of that, well, the average of this would be 6.88 or 6.9. But if you want to take the mean of that, the median of that, I mean, the median of this is basically the center area of it minus the extremes, and that comes out with a value of 6, which is different than average. But it's the reason median is useful is that it gives you the ability to look at bell curves and chop off the ends of the bell curve in order to get a better answer for where you should be sitting in the center of your overall data set. So all that makes sense? Any questions about that? It's also a good way to get some of your math homework done quickly is by using the mean function within Excel. Some of the 100 level math topics cover things like this. But yeah, I mean, ranking, it's the number or reference in the order given it. A order of 1 is a increasing, an order of blank or 0 is a decreasing. So that tells you reverse order. But that's basically how it's used. So hopefully you guys find the ranking function useful to you someday. It's good for extracting information about various pieces of data. In the Excel, or inside of IntelliPath, you'll get some random set of numbers like this, and it's going to ask you for how to determine based on this. Is like, all right, you got these things in, you use the rank function to get your data set organized, and then you have a questions like in this case, suppose you're teaching a class, the principal wants you to meet with students of the top 20% of the scores. The 19 scores are as follows. Well, those 19 scores, top 20% means you're looking at the top 4 people because you have to break it into 5 zones. So once you figure out this data set, you then sort it or use the rank function on it to then it's like, all right, well, if it's, say I needed to use the data validation and I needed to do it based on 4 zones, I could say any whole number between 7 and 9 or 7 and 10, right? We'll just say that 7 and 10 is an acceptable answer. So then I could say, all right, I now know that these are my valid numbers that meet that criteria. So so you can use data validation. You can use all these different pieces together in a manner that makes it easy to kind of answer. So when you get to this answer here, right, if you put in those same numbers, do that same kind of thing where you can validate based on figuring out where your ranges is and your top 4 is, you could then say, all right, in that case, the answer here is 4. There were 4 students with the rank 4. That would be part of your top 20%. So, or not rank 4, sorry, 7. 7 of the top 3 students all scored 96.4, and then of the top 20% would be 3.8. So, yeah, it's confusing. Okay, so, but biggest thing is you also need to eliminate duplicate scores in order to make ranking get useful, because it doesn't handle duplicate scores very effectively. But yeah, there you go. There's how you can answer the ranking score question. Logic charts. Cough and hasn't gone away for over a week now. If you were coming with logic, right, and the logic question is like, all right, if 1 represents true and 0 represents false, then the rhythmic expectations results of a logical set. X times Y is and, what expression is or? So the correct answer in this case is 1 minus X and times 1 minus Y, which you would never be able to figure out from that context unless you actually tried to do a logic function to get that. So, and the idea is in this case, it's trying to tell you it would be if you took those together and you multiply them together, but just the or is that is like the inverse of it, right? So something along those lines. But if you needed to do other things like, well, if you do a comparison and you're doing an XOR 3 versus 6, you wanted to figure out which was greater. The answer here is the XOR is a false because 3 is not greater than 6. In the case of 4 is greater than 3, you get that answer of it's greater than. If they're equal, you can get an answer of equals. And that's kind of what this formula is telling me is like, give me a comparison using the XOR function, using the if statement within Excel to come up with the answer of that. Mathematically, it would look like this function. In Excel, it's written like this. So, I mean, both of those give you the answer, but both of these will give you the same answer. It's just that if you needed to understand what your answer is, that's where you can do this. We use an if statements in order to give you more detail. So, but this is how the XOR function would end up mattering in this context. Now, if you needed to do things like the nots, right? In this case, 2 trues are the same with a not function. They both come out valid, and the not is not valid or not true. Since they're both true, not true equals false. When you have a true and a false with a not function, it'll say true is true, false is false. The answer being false. With, in this case, it's going one at a time through here, right? True equals true, true equals true. It's not true. True and false equates to true once or more, but not that is false. Now, if you do the other way, it's like, all right, let's get the inverse here, and then 2 falses make it true in how the logic of Excel works. So, or math works. In an and thing, it does is like take these 2 values, to combine them, 2 trues make it true, but any false will make it false. In the case of an or, any true of any values make it a true, but if there's no trues, you get a false. Now in XOR, 2 trues together make a false. So basically these have to be equal in order to get the false on the XOR side of that fact. Hope that was clear. For 2-dimensional truth statements. So if both are true, in the end, if both are true, then it's also true. If both are not true, then it's considered false. In a case of an or, if either are true, then the result is true. In an XOR, if both answers are the same, it's false. If the answers don't match, it's true, which is where that comes down. So XOR can only be true if exactly one answer is true, when you have a lot of these in series. So, and if more than one answer is true in an XOR, then the answer is always false. For logic gates, that's how circuitry is decided within a computer, for instance, right? So we got these fantastic little phones and computers that we work on all the time. But in order for it's making trillions of these decisions every second on how to do things. And it's based all on basically XOR gates. So on how to a computer actually functions whenever it takes any bit of data in and processes it. So under Excel, if you look under formulas logical, you can get this information here pulled out of your book. This is the this is how the math class inside of CTU teaches the XORs, and function is this way: is and returns true if all arguments are true, or returns false if all arguments are false. Function of not changes false to true and true to false, and the if statement checks to see if its conditions are met, and then returns it. And XORs is returns an exclusive of all arguments. So, but like I said, if any one answer, if there's only exactly one answer true in an XOR, the answer is true. Otherwise, it's false, right? If exactly one answer is true, otherwise more than one true is actually false. So if you needed to do this if you built the functions to look at this like this, these are what the functions would look like to get those various things. So by creating that table in Excel, you can then figure out how many ands and ors and trues and falses you're actually creating by doing this. So do I have that in do? So with that in mind, let me see if I can pull these up side by side. All right. I'm not sure how well you're seeing both of these side by side, but if you took that set of functions here, which is what the formulas here are on this, and then you put it in there in the AND function, only this first row here, row 11, is true. All others are false in that context, because it has to be all three arguments here have to be true in order to be a true. Or all four arguments, sorry. There's four arguments. Yeah. No, not even using this set here. Okay. Yeah, deal with that later. So in these three arguments, all is true is true. If here you got one is false of these three, so you get a false. Same thing all the way down there. The or, it's the not the opposite of, but it's if any of these are true, then the answer is true, which is true all the way except for here where it's only falses. And then the XOR, it goes it by a sequential order of deciding these two, and then it takes that comparison of here. So it goes true, true, compared against true. True, true, compared against false. True, false, compared against true. False, true, compared against true. True, false, compared against false. So you see how that last one changes based on the results of these can flip that number. So that's how that actually works. Same goes for the comparison of two there. I showed you the if greater than equals trick here with that chart is there. There's the how it actually works out in the end. There's your XOR statement, and there's your definitive logic statement to tell you how to read that. So, okay. Hope that was clear as mud. Where was I? Yep. So you can do conditionals with the if statements to compare against things in order to get answers. So if M2 is less than N2, and say is 1 less than 5, yes if true, 0 if false. So in that case, is 2 greater than 6? The answer is false. If 3 is equal to 7, the answer is false. If 4 is less than 8, the answer is true. So that's how, here you have an example of using the if statement to do logic testing. If logical test, value of true, value of false. And usually people will actually quote the word true and false in this context, like I did in the other example, so that you can actually follow that along later, instead of just turning things to ones and zeros. Date function, you can use today function to get today's date. Today plus 7, so a week from today, plus 14 is 2 weeks from today. So you can then figure out how to build calendars in such a manner to do that. That's kind of a nice feature of the date functions. Dates and times, in that context, if you try to build a calendar, you can then have it set up so you know all your different pieces of information, number of days between, as an example, what they did without weekends and with weekends. Anyways, pivot tables, then you can take that data, build a pivot table, and it's great for summarizing your data. So it allows you to at least look at bits and pieces. Once you work on your data set, once you get all your logic down, then you can build a pivot table based on what you had for your outcome of your logical things. And that's how you can string multiple tables together to then create a pivot table that you can then extract even greater information out by doing it. Skip that piece. So now, in order to build a pivot table, you take your data set, you highlight it all, you start up your pivot table here, and then you create from your data set in order to build it, and then you can create that type of stuff from it. So if I were to do that live, it would be, say I take this data set, I could go recommended pivot table. Let's go with this one for once. Years by course. So you could say the years of the students and their years that they're in, and you can tell how many students are in well, that didn't seem as useful as it sounded, but that's how you do basically a pivot table, right? You just highlight the logic, highlight your group here, say pivot table, recommended pivot tables. So it has a set of default recommends it can do. In this case, that might be the, yeah, this is an example of one pivot table type. If you do the recommends, you don't get necessarily all the additional features you would expect with it. So if I were to say, do this again over here, just do pivot table of my own, where I have full control of it. I say, all right, this is my data set. I selected my range. It shows my data set as pivot chart. I will do it on new worksheet over here. Oh, that was weird. Why did it do it that way? New chart. Yep. Music thing. I must have got it confused because there's too many pivot tables now embedded inside. But anyways, that's how you end up creating this kind of build, is by highlighting it and saying use pivot table. So that's where the step-by-step instructions on this particular page was about. And there's a couple YouTube channels there to help you with creating of pivot tables for this purpose. Then you can figure out if you want compact form, outline form, tabular form, so your layout and your formatting of that. And once you're done, you can always then use OLE to embed your charts into a Word document or PowerPoint for presentation purposes. But that's kind of how all that works. So in the discussion board, going back up here, just how do you use it to make critical decisions is the question, right? So how do you take this data? What do you do with the data? Once you analyze this data, you got it set up in a certain order. Question is, what are you going to do with it in order to make any substance and use out of it? So ideally, you can make it to make information more understandable, clearer to read and explain. You could use it on your own degree to track your progress. Obviously, we have the app now in the phone, which tells you your percentage of completion or a number of credits completed over time out of the however much you have to do. That tells you the donut view of what's left percentage wise. So I don't know, any questions on any of this so far? I want you guys to send me questions and email too, because I need new material apparently for these charts. Yeah, I can use some new questions, new material for some of these charts. So, all right. Well then, I will set this up so to share a video from YouTube then.
It's time for another math easy solution. Turn to discuss an extremely powerful tool in Microsoft Excel. Basically go over pivot tables and pivot charts in Microsoft Excel and go over an introduction. You can do a lot more advanced stuff with pivot tables, but I'll do that in a later video. Basically, what pivot tables does is allow you to analyze dynamically lots of data very quickly, which is quite amazing. I'll go over this example. This is just a small table I made where this just has the date up to, I guess, March. And there's the type of each row, sales or expense. I just had these two. And this cost, this I just use a random function. This is all just random. And there's a tax. This one is a 12% tax. So as you can see, yeah, this is just random data. And then with pivot tables, it allows you to analyze all these very quickly and dynamically. In my earlier video, I went over automated tables, so make sure to watch that one. That's to just modify this table by itself. But with pivot tables, it allows you to do much more and quicker. So for you highlight it all, click insert. So you can go pivot table. I usually click both pivot table and pivot chart. So it allows you to do a graph what the table is. So there's our data we selected. You could also use an external source. And you could also now here choose where you want to add your pivot table, either new sheet or existing worksheet, and just pick a location. You could even add this data to a data model, which is multiple tables inside a pivot table. And I'll go over that in a later video. So if I just click OK, just in a new sheet, So now this is our pivot table, this is our pivot chart right here, and this is the data that it's connected to. And as you see here, there's pivot chart fields. So this allows you basically to, to group and modify your data visually. So you can go, let's just say we want to, okay, so we want to graph the date and the cost. So I just click them. You could also drag and drop like that, etc. As you can see, that's multiple layers taken out. And as you can see, this table automatically changes, and now this chart automatically changes as well, which is quite amazing. So I click the tax on there, and there's the graph shown there. I'll make it on its own just to see it better. So move chart in a new sheet. Okay, so that's how that looks. I'll just change a chart type. You could change it using a combo, different stuff, or I just like using the line. Okay, so this is the date now, and that's the red is the tax, and the blue is the blue is the cost. So as you can see here, with this one here, these values are the sum. So we're using sum, and this is and you could also change it to average, etc. So when we go back to our data, as you can see, this is what it's being plotted. But since all the rows every single day is different, then you're gonna have each day is gonna be different. So whether you use average or sum, it's gonna be the same thing. What if we were to modify it right here? Let's call this January 1st, 2015. Yeah, so now we have 2 days that are both January 1st. So if we go back here, so it hasn't updated, so you would go analyze. Now you could refresh all your pivot tables, just click all, there's only one. So anyway, so now as you can see, there's only one January 1st, January 2nd has been skipped, but now we've added the sum. So that's quite amazing actually. We just added these two. So 232 plus 552 is equal to 784. And now what you could do here is change this. Let's go to average. So if you go average, so there you go, that's an average 392. It's taxes an average. You could even go yeah, you can even modify to the max or other stuff like this, max, or you do a product of multiplying two numbers or something, and then you could do that. I'll just stick with the sum. So we go back to it here, and now the cool thing is you could use this filter one. I'll put this this filter right here, which is quite amazing. So as you can see over here at the top, you click it, you could either select both of them, or if you have a lot of them, you can select multiple ones, or select one at a time. I'll click expense only. So now we're looking at only the expense, and see how quickly I was able to do that? I quickly able to see the expense plus the tax spent. So it's total. Change it back to sales. Yeah, and there you go with the sales. It's super quick, and you can see that. And then you could also, let's say you don't want to do this filter thing, you could just throw this filter into the legend. So now you'll have both of them at the same time. Yeah, so this has now there's four stuff. There's the cost and expenses, cost of sales, tax of expense, tax of sales. Yeah, and the chart, they don't connect to each other. Yeah, they don't connect each other because the data I did was random, so there's a lot of dates without data right there. And now a very useful and very cool tool you could do is in this to make it just a bit more easy to see, because just deal with instead of daily, look at monthly revenue, etc., etc. Go back to now our sheet 2 where it has our pivot table. You can right click here or pretty much anywhere you want to right click. So let's go on the row labels, which is the date, and we can group it now. We can group it by minutes, days, or months. So I'll put this by the month, which is super cool. So now we have 3 months worth. It has the sum of cost, the sum of sales, that's the sum of expenses, and the sum of sales, and there's the taxes, the summation, and you can go here quickly change into, let's say, an average. So everything's an average, or the cost is an average, the taxes still sum. So this is quite amazing, like just the speed that I'm able to analyze all this data. And as you can see, there's a total sales. You can see the monthly one super quickly, and all from this blank data right here. And now, as you can see here, you have the monthly one, so it looks a lot better now visually. Let's change this chart type. So you could also, when you go change chart type, As you can see, you could plot these. You can make them as a secondary axis, etc. So you could make the taxes on the secondary one or the primary one, or all of them the same. Let's call now. You could change these each one separately, or you could do all at the same time. I'll just go to columns. I'll make it like this. So as you can see, there's our monthly. Oh yeah, so our expense. I did a random function, so in this case we're losing a lot of money. The cost is how much we're making. This is the sales, there's expense, and there's our taxes of both of the two. As you can see, this is super cool. You can visually see that, and the fact that we can create that. I just created there all in one go from this data source right here. But anyways, that's all for today. Hopefully you learned from this. Also, I just want to quickly here. You could also change if you right click there. You could change. Yeah, so if you right click any of these, go format data series. There's another whole data series around here. You could change how it looks. You could click plot on secondary axis. So as you can see, the red one, yeah, this one becomes on the secondary. If you want, you could also right click this format.
That's basically lots of different things you can do with pivot tables in order to build out answers to various questions, concerns. It is quite powerful tool inside of Excel. So really, the biggest thing is once you learn how to manipulate data, then you can get into pivot tables to figure out how to resolve all kinds of different questions you may have to do by deep diving into the data you have. So, all right, that's all I have for the class today. If there's no questions, appreciate your time. Remember, get your homework done, get your work on it. I'm going to keep on accepting the old all the way back to week 1. Give you a chance to build a new high score inside of your your effort. I hope this was useful to you. Definitely send me new questions because I could use new material in these charts. I'm going to be teaching this class again next quarter as well. So thank you, everyone. All right. No, thanks for your time and have a nice day.